So thank you to everybody who's come out. My name is Murthy Prakasam from Informatica, and I'm joined with my colleague here, Sumit Agarwal, also from Informatica. And we wanted to do a session here that's kind of focused on, I think, something that's becoming more and more hot in the area of Hadoop, which is this idea that, what are you going to do with Hadoop? You're actually trying to empower analysts, right? Ultimately, there's somebody in your organization, or maybe it's yourself, who is trying to get value out of the data that's in Hadoop. And I think one of the things a lot of people are struggling with is, like, how do you actually kind of design a system around Hadoop so it actually enables your analysts to have relatively autonomous access to analytics? And there's a lot of nuances in exactly how this is done. And one of the things you always see at a Hadoop Summit, there's sessions that are very visionary, very futuristic. What we thought is we just do kind of a very practical session around what we've seen from other existing customers that we have, how they've gone about kind of the best practices for designing data pipelines so they can ultimately achieve what I think all of us are trying to do, which is to get to more autonomous and more trusted analytics. So I'm going to do just a couple slides that hopefully aren't too boring, and then I'll hand over to my colleague here, who's sort of the father of this whole area at Informatica. So he's going to do a bit of a demo so you can actually kind of see what a lot of our customers are doing. There we go. So you're probably going to see this exact same slide in almost every session, so I won't spend too much time on here. But I think we all kind of generally understand the opportunity that all of us have in this new world of big data. That obviously, data management has always been focused on a lot of relational data sources, but now there's a whole new set of sources, and I mean, this barely even covers the list of the types of data that you can bring into your organization to drive greater analytical insights. And so, I mean, this is just, like I said, a limited list, and I think moving forward, we're going to be seeing all kinds of fascinating analytical use cases. I mean, all of us are wearing these devices now. I'm wearing my Fitbit today. It's amazing the kind of data that's being captured literally as I'm walking around, and the kind of analytics that can be provided. So each of you has that same opportunity to leverage some of these new data sources to drive interesting analytics. The remote's kind of slow here, so. Right over there. Oh, gotcha. There we go. I think it's just a little bit delayed there. So the opportunity of Hadoop, again, we don't need to cover something that's somewhat obvious to probably everybody that's at this conference, but obviously Hadoop offers a new platform for processing these new types of data sets. Very flexible, very scalable, very efficient. So I think nothing here is sort of a surprise to anyone. I think we all understand the opportunity of new data and the new platforms that are available to process that data. So the issues that I think a lot of organizations are facing, again, we're talking about practical issues that organizations are facing. Number one is that a lot of the burden of preparing this new data, and the new data is obviously inherently unstructured and very, very raw. A lot of that burden of preparation ends up being pushed out to the analysts. And again, this whole session is about helping our analysts. And so any time that you're spending on preparation and all this other work that's not really directly related to analytical value is time that you're not spending on analytical value, right? And so ultimately, you want to get the data scientists, your business analysts, as productive as possible. And this is a challenge that a lot of organizations are facing, is exactly how do you get around developer and analyst productivity. The other side of this, which is sort of related to the first problem, is if you actually don't get the data to the right people on time, some of these data sources are very, very real time, like social media, a lot of the sensor information that you're seeing, manufacturing companies, energy companies looking at. Like, you basically have to act on the data within a certain couple minutes, maybe an hour. And if you don't, the data is not useful. So the whole point of actually even getting at some of this high velocity data is being able to actually process it very, very quickly. So if you've got that first problem where the analyst or developer is the bottleneck, then you're actually not getting the value of the data. Another aspect of this, which also obviously we can kind of see at this conference too, like every time you go to a Hadoop Summit, you go to a Strata, it's like they've invented 3 more new languages, and so, and it's great. I mean, on one hand, I think there's a lot of innovation in this industry. Like, the innovation actually in the industry is probably one of the most exciting things about big data. The flip side of this, again, we're getting into sort of practical issues for the average enterprise. You can't continue to have the same developers go into a new training class every 3 months to learn the next new framework. And so sometimes the bottleneck to productivity is just the fact that the skills themselves are sort of hard to pick up, or there's always these new skills. And then that leads to the second problem again, which is if you're changing platforms, you're changing skills, how do you actually get any kind of repeatability? It's not like an analytics that you're doing, you're going to just do it once and then kind of move on. Most of the things that organizations do are ultimately going to be operationalized, whether it's a report or whether it's some sort of a system that's going to process the analytics. It's not like it's just doing it once. You're going to be doing this on a repeated basis. And so you obviously need to kind of tackle this issue of reusability to actually enable scale and repeatability. And then, of course, we talked about just the nature of the data itself. So it's pretty exciting that we have all these really, really new types of data sources, but they usually typically don't come in perfect form. A lot of this, by the way, is because the data itself is generated by human beings. So you look at like social media or web logs. I mean, when was the last time you actually really spent a lot of time thinking about the information you were like typing into a web form? You know, most of the time I'm just trying to get through the form as quickly as possible. I almost intentionally will leave a lot of fields out. And so you end up getting kind of information that's incomplete, it's inconsistent. I mean, you know, you get the whole like sort of variation on names, variations on addresses. All of this ends up impacting analytics because somebody at the end of the day has to go back and say, oh, Jonathan is the same as John, or you know, what you know, does this zip code map to this address? All of this becomes work, again, that is a burden on the analyst or a developer and really shouldn't have to be. And so, I mean, this is sort of the summary of all, you know, ultimately this is just kind of constraining analysts. You're trying to get to more pervasive, more autonomous, more trusted analytics throughout your organization, but you've got data silos that are all over the place. You know, on one hand, again, this is the flip side of Hadoop being such a relatively easy platform to kind of install and get up to speed. It's like you have now this proliferation of Hadoop clusters all over the place. You've got data silos everywhere. People are waiting a long time because of all those things that we just talked about in terms of preparation, like actually thinking through the practical issues of getting raw data into a form that analysts can consume it takes a while. And then, you know, again, just the whole notion of reusability, repeatability, like maybe you'll go through and do a heroic effort and get one project knocked out. Now try doing that 10 more times or 100 more times. And so these are some of the issues that we've been trying to address. So basically, we want to help enterprises get to data that can be trusted as quickly as possible. So let's try to shorten the latency to get to great data. Let's get insights that are timely so that, you know, as you're collecting some of these new data sources and they have very short latency requirements around actually being able to act on the insight, we can actually address those requirements. And then let's also help to make this not just a one-off project that, you know, is a heroic effort, but let's make it an operational, simple, repeatable, reusable kind of process. And ultimately, we think if you combine all of that together, you're inevitably leading to productivity and autonomy for the analyst. And that's ultimately what matters. So this is kind of the idea, I think, of the session here, is really how do you design for autonomous analytics? How do you look at the analyst, which is the really end goal of everybody here. This whole conference, I think, ultimately is about there's analytical users. We want to help them, empower them, make them autonomous, get them as much data as possible, and get as much trusted data as possible. And so the idea that we have here is this, it's almost, I hate to use an analogy that's sort of overused, but it's this like a notion of a supply chain. You know, people know this in manufacturing, that you start with raw materials, you kind of go through a manufacturing process, and the output of that manufacturing process is the finished product. Well, data is kind of the same thing, and there's a lot of, you know, fascinating articles and blogs about, you know, data lakes, and is it a data swamp or is it a data reservoir? And so I actually think if you look at the customers who've been very successful with this, they've actually embraced this. It's not necessarily a problem. They've actually understood that, yes, when you ingest data from all these distributed sources, it's kind of a swamp. That's okay. That's the whole point of Hadoop, is that you can actually land data in a way that's very, very raw, very, very quickly, very, very easily, but just acknowledge that that's not the thing that you're going to hand over to the analysts. That's just your first step. That's you ingest, put it into something that maybe is a bit of a swamp. Not to use that term in a negative way or anything, but then there's some preparation steps. So you're going to do some profiling. You're going to do some parsing. You're going to put some structure to the structured data so that there's meaning to it by looking at some of the metadata. So then maybe you sort of turn this into, and you can make up your favorite phrase. You know, is it a data pool, or is it a data whatever, grid? You know, there's all kinds of words out there in the industry. And then there's sort of maybe a final step of like cleaning the data, understanding relationships, and you kind of eventually get to this point after you've gone through a manufacturing process that's the thing you give to your analysts. And I think this is sort of the great idea here that we're proposing, which I think the best customers seem to be getting around this idea that, yes, ultimately Hadoop is a platform that gets you to analyst productivity, but there's this thoughtful process of getting there. And if you nail this sort of design process, this manufacturing process, then you ultimately are empowering a you know, even greater number of analysts in your organizations to get access to this data. We also have this concept, and Sumit is going to show you this, you know, in his demo, of this idea of data intelligence. It's a very, very new concept, but the idea is everybody here is familiar with business intelligence, right? Business intelligence is the reporting you do on the data. You look at the data, and you can do your aggregations and do queries on that, and you develop reports. So we have this unique technology called data intelligence, which is where we actually are performing machine learning and intelligence on the data set itself so that we can help you with this manufacturing process and make it more automated and more intelligent. Because again, the whole idea is, even there are probably some companies who understand that there is a manufacturing process, but they're doing it all on the backs of manual developers and analysts. And that doesn't really scale either. You can't just keep throwing people at the problem. If you think about the curves of how data is growing in organizations, you're not going to address that curve with people, or it's going to get really expensive really, really quickly. So you have to get to a technological and hopefully an intelligent solution so that you can actually address the volume of growth. And that's the idea here, really. It's how do we kind of design around a manufacturing process for data and use some intelligent machine learning algorithms to actually accomplish that. So I'll just go through a couple of last slides here just to kind of describes what each of these concepts are. So I won't read through everything kind of on this slide, but this just gives you a couple of the notions of what data intelligence is. I kind of give you a really quick definition. I don't know how many people here took the SAT a long time ago. I know I took it, and I don't really have pleasant memories of it, but one of the things you used to do on the SAT was do these analogies. So I kind of think of, if you weren't trying to understand what data intelligence is, well, business intelligence is kind of the intelligence that business analysts use, to do reporting on the data. Whereas data intelligence, if you're a data developer, data architect, which is probably the people in this room, this is the information that you need in terms of the structure of the data, not the actual analytics on the data itself, but looking at the structure of the data, looking at the metadata, understanding relationships between data. If we can intelligently understand those relationships, we can help execute that manufacturing process in a much more efficient way. I hope I didn't make anybody have bad memories of going through high school and taking their SAT. So a couple of things that we do that kind of fulfill this idea of using data intelligence to accelerate that manufacturing process. We provide pre-built parsers and connectors to, it's over 200 sources. I actually couldn't fit all of them on the slide, so I just kind of listed out a couple of the common ones, but you can get a complete list on our website. But the idea is, one of the biggest things that a lot of enterprises face is just connecting to data sources and like ingesting the data into Hadoop. And I mean, there's all sorts of sort of manual ways to do it, but like we have pre-built connectors. It's the same problem that everybody faces. So you might as well just use something that's off the shelf and just not even spend any manual time on it. This is one of those like no-brainer, low-hanging fruit type of problems that you can easily solve. Just use pre-built connectors to data sources, use pre-built parsers. You immediately have solved like the front end of that manufacturing process without any manual code writing. We also have data quality functionality. This is part of this machine learning technology that I was talking about. So if you have so here's like a little piece of text, like maybe it came in on a tweet or something like that, or it was in an email. So our technology can actually read and parse through natural language text like this and say, oh, there's a name in here. It's Bill Harrison. And by the way, Bill also can mean William. So if we're trying to match this against a different data source, we'll match against William as well. And oh, there's two stock tickers in this message here. So that maps to different companies. So maybe if we're trying to relate this message to some other data set that we have, we actually know what the data is. So this is the advantage of this technology, where instead of having a human read the text and say, oh, there's a name in here, there's a company in here, we can actually do that automatically. And that's technology that just radically accelerates your ability to take raw data sets like this that could just be in free-form text and actually put them to analytical use very, very quickly. We also are able to use this kind of on a defensive level as well. So one of the things, especially regulated industries, if anybody here is from like a healthcare or financial services, you really, really have to care about personally identifiable information and things like credit card numbers and addresses and phone numbers. So it's the same sort of pattern matching technology that we have. We can actually go through data streams and identify that, oh, there's some data here that is part of some domain that is something that we consider sensitive. So based on that analysis, we can identify any data very, very quickly. We can surface this to you so that if you need to go either mask this information or just eliminate it from the data set so that whoever your analytical users are don't have access to it, you have the appropriate remediation options, which again gets to be very, very difficult when the data sets are very, very large. Like actually picking out where some of these sensitive data sets are from the vast majority of data that you have is again something that taxes a lot of organizations, and we can do it very intelligently. Another application of this data intelligence technology is metadata management. So this again goes back to kind of a compliance use case. So there's a lot of industries where any data that you're processing, you have to have an audit trail of how the data has been transformed, how's it gone from one system to another system, who's been accessing it. So since we actually see all of the data set, both in Hadoop and outside of Hadoop, we can provide those audit reports. So this is absolutely critical for any of those industries, again, where you have to sort of produce this audit. And so we work with the Hadoop vendors on this kind of technology, so we can see all these transformations that either we're performing inside of Hadoop, or even as the data is moving in and out of Hadoop. We see all of that, we capture it, we can track it, and so this becomes absolutely critical for any industry that needs that kind of auditing information. I talked a little bit about this too. So one of the remediations that you might do once you've identified that you have sensitive data is you might want to mask it. So it doesn't have to be a 0 or none where either you give access to somebody, give access to data to somebody, or you don't provide access. You can also have this kind of intermediate solution where you mask the information in a way where the logical structure of the data is actually still intact. So the phone number might be converted into some other phone number, and we know in the background that there's a relationship with these things. So now an analyst can still do some kind of analysis that requires a phone number, but it's not the actual real phone number. So these are some interesting ways that you can enable your analysts to actually still access sensitive information without actually seeing the raw information in its plain text. We also taking this technology to the space of master data management. So for folks who are using master data management systems, you're getting all this new data from these new sources. So you want to actually use big data to append to your existing master data management system. So we have a version of our software which runs again inside of Hadoop, where you can actually do matching. So as you have new data sets coming in, we can ingest it, we can actually do some fuzzy matching. Again, this is this machine learning technology that we have. So we can actually say, oh yeah, we have somebody in our database called William, and here's a tweet about Bill, and based on some of the other characteristics, there's a high probability that these are the same people. And so we were able to actually get greater meaning from data using this kind of machine learning technology. And this is all work, again, that your analysts or your developers don't have to do manually. So this is I don't know if you guys remember this commercial from the 80s where they would show I think it was a commercial for against drugs, where they said this is your brain, and it showed like a picture of an egg, and they'd say this is your brain on drugs, and they had show the egg frying in a plant. So I always thought that was kind of a cool way of showing this. So this is sort of what a transformation, like kind of data pipeline work looks like if you're going to do it by hand. And I mean, I'm reasonably technical, but I know I can't figure out most of what's going on there. So here's what it would look like if you're using kind of this machine learning and data intelligence technology that we have. It's completely graphical because all of the underlying execution details are just buried underneath. So your team, whoever's responsible for this kind of data preparation work, they just draw out the interface. And I mean, most of us can look at this and probably figure out what's going on here, right? It's like there's a couple data sources, I'm joining them between two data sources, I got a couple more operations, and I'm gonna write it out to you can just look at it and actually tell what's going on. That's the power of this technology, that you don't need to have this expertise in all these different languages and then have all this code that you have to maintain. You can actually write most of this stuff in a higher level language and then have the execution just happen in the background. And it's just less work on your teams, easier to deploy, way easier to maintain, because like again, you could look at this a year from now, a new developer could come in and say, oh, I know what's going on here. I can make changes and modify this very, very quickly. So basically, I think if you wanted to kind of summarize the whole presentation, and then I'm going to hand over for the demo here, I think the ideas that we see most of our customers is they think about designing for autonomous analytics. And I think this is really the core of, I know we talked about a lot of different features and how we use machine learning, but really the end goal here, all of you are trying to serve, or you are the analyst yourself perhaps, you're trying to get to more autonomy and greater use of your data. So number one, design for standardization. And this is one of these things that I think is slightly controversial in the space of big data, because I think there's a sense that, oh, well, since the data itself is so varied, and so it comes from different sources, that it's inevitably going to be very heterogeneous. But every single customer that I know who has made maximum use of the data, yes, they obviously are ingesting data from a lot of data sources, but at some point, they create some very, very lightweight standard. It could just be saying that all the data, before it goes into Hadoop, it should be turned into JSON format. Something that's simple. Like just having every single team conform to one simple format like that radically enables downstream analysts. Because now everybody knows, okay, I'm going to query on JSON, or Parquet, or ORC, or whatever the format is. But just getting everybody on the same page, huge productivity enabler for your analysts. Number two, like I said, designing for speed. Don't make your analysts or your developers go through all this manual process that they're going to do over and over again, and then somebody quits, and then somebody else has to go figure out the code. Like, just design for automation up front so you can get these things rolled out very, very quickly, because that inevitably also leads to agility as well. Design for reusability, and we talked about that. The more you can kind of make this something that's systematic as a part of a manufacturing process. Again, it seems sort of controversial. Isn't big data supposed to be just like the Wild West? And I mean, the reality is, if you look at the most successful customers, they end up building these kind of manufacturing processes, because that's how they can actually use big data repeatably and reusably. Designing for security. So we talked about the masking features and things like that. The last thing you want is to go in just a whole bunch of data and then tell your analysts, oh, sorry, we can't give it to you because it's got sensitive information, and you can only look at like the really, really surface level stuff. So if you actually design with security in mind, you can make a greater amount of data available to your analysts, and that ultimately leads to better analytical outcomes. Designing for auditability. We talked about the metadata management and the lineage tracking. So whether you're doing this because it's the law, which is obviously a good reason to do this, or maybe it's even just for your own internal controls. Maybe your legal team or your finance team just wants to have some way to audit what all the stuff that you're doing as you're adopting big data. So there's simple ways to design the auditability into the process, and it just takes out a lot of risk and a lot of pain later on. And finally, again, design with your analysts. So if you're not an analyst yourself, one of the things we've always seen our customers say is, if I'm in IT or I'm a developer, like, go work with the end user of the analytics and really kind of figure these solutions out collaboratively. I mean, a lot of the things we're talking about here seem pretty straightforward, but it's amazing how just the psychology of working in a kind of agile, collaborative, I mean, we see this a lot in just general software development, but I think the Hadoop space in particular, we're seeing this pattern again. Get small core teams that have analytical users and data developers, IT people working together on these projects, because then you kind of get this immediate feedback loop. And also the fact that you're doing all this work to empower them, there's some immediate recognition for that. I think everybody who's in an IT role always looks for more and more recognition, because you typically don't get it. The greatest way to get to that is we execute these big data projects with your analysts in mind. So with that, let me go ahead and turn over to my colleague here, who can actually kind of give you a really, really good visual look at the process here.
Thanks, Murthy. Can you switch to my laptop? So first of all, I'd like to thank all of you for staying with us, especially during the lunch hours. So thank you all. And I'm not going to bombard you more with the PowerPoint slides, and I'm going to show you all the best practices which Murthy described. I like his last slide where he kind of summarized everything. So what I've done is I'm taking a very practical problem, which Murthy has said like in the beginning of the session, right? We're trying to solve a practical problem. So what I've done is I've taken a very practical problem, and then I'm going to apply all these best practices which Murthy has just described, and see how we can solve a real-world problem. So for this demo, what I've done is I've taken a healthcare sector, and I'm trying to find out a way to reduce the reimbursement cost for this healthcare provider. So think of this, right? This is an insurer who wants to reduce claims and reimbursement cost from all the providers in hospitals and clinics. So if I'm a health, suppose if I work for a health insurer company, I get a lot of claims from different hospitals and clinics. What we want to do is we want to analyze all the claims which are coming in a HIPAA transaction formats, and then find out what all providers are performing well over a period of time. And the way we find out the performance of these providers, basically by checking how much time they take to cure a particular disease. And then based on that, we are going to do some analytics. And there are two roles which I'm trying to showcase in this demo. One is Sarah. She's a business analyst whose main work is to give recommendation to business that how to reduce the claim cost. And then we have Sam, who is an IT developer, whose main responsibility is to help Sarah to come up with this decision. So this is the whole process where I'm going to use for this demo, where I have a provider data sitting in my transactional system like Oracle. The first thing I need to do is I need to read the data, move it into HDFS, or Then we have to clean and profile the data, find out what is inside the data. Then we are also getting HIPAA files, which are semi-structured files. We need to have a way of parsing the file and make it in a standard mode which can be used for me for analysis. And then we also have some member data where we want to do some fuzzy matching because we want to make sure that all the claims which we are getting from patients, those are real claims. Means they are not like fake or fraudulent transactions. So we also want to make sure that everything we are getting is really members of the provider. And after all this, we need to mask sensitive data, all the things which Murthy talked about, that how can you mask sensitive data. And on top of all this, we need to have a way of visualizing everything through any BI tool like Tableau or MicroStrategy. And then we need to have everything with the governance. So you need to have the end-to-end lineage of all the things which is going on in this demo. So with that, let me show you a product. So what I've done is, for purpose of this demo, I've taken I've taken a one-node Hadoop cluster on my laptop, and I'm demoing from that for that. So this is our tool. This is our Informatica Big Data Edition tool. So just a show of hand, how many of you are familiar with Power Center here? Can I do a show of hand? Okay, so it's like 50%. So Power Center, so we are, Informatica is known I think we are like 20 years old company, which is our main flagship product was Power Center. And this is our new tool, which is called Informatica Big Data Edition. And this is totally based on Eclipse, where we have, where you can design your workflow purely in a visual format. So the first thing I did for this demo is to design the whole pipeline. Like how will I move, how will I have different steps to solve this use case? So like in my first step here, so those of you who are not familiar with Power Center, think of this like Uzi, where I'm trying to create a workflow and trying to orchestrate and schedule it. So in my first task here, I'm trying to ingest raw data, which is sitting in my Oracle, onto my Hadoop system. Once I have my data in HDFS, in my next task, what I'm doing is I'm cleansing the data quality problems from my raw data. Once I have the clean data, then in my next task, I'm trying to parse the HIPAA transaction files, which are the claim data. I'm trying to merge it with the provider data. Then I'm trying to do the fuzzy matching part to make sure that there is no frauds involved. And then in the last, I'm trying to mask the sensitive data. So I'm going to show you all these things quickly. So this is the first task which I have done. So like Murthy said, Informatica gives you a visual way of visualizing everything or giving everything in a metadata-driven way. So in this mapping here, I have Oracle source, and you can use our product to give a preview of your data. So I can run a preview and find out how my data looks like. So what I'm doing in this one is I'm just moving my raw data, which is sitting in provider Oracle, into HDFS. So once I have my data into HDFS, and as you guys might have hearing in this conference, is Hadoop is schema on read, where you don't actually know what your data is. So for that, what I've done is I've run a column level profile on my data, on my provider data, which I just moved in HDFS. So when I ran a provider level, the column profile, I can actually see patterns, and I can see different patterns of data to see how my data looks like. So like, for example, here in this, I'm running, sorry, this is a live demo, so there's some internet connectivity problem here. So what I'm doing here is I'm trying to run a preview. I'm trying to run a column level profile of my data to find out what is inside my data. So like, for example, here, it actually gives me the patterns and frequency of everything which is there in my data. So by looking at this data itself, it gives me a feeling that this is not a good quality data. There are some problems with city. If you look at this, city is spelled incorrectly here. Sometimes the zip code is wrong. So I definitely, using our column level profiling, I'm able to find out inside of a data. So once I know that there is a data quality issue, what Informatica provide is, as Murthy said, we have a rich data quality transformations, which helps you to cleanse your data which is sitting on Hadoop. So that's what I've done here. I have taken the raw data, I've profiled the data, I've found out that there are some data quality issues, and then I'm using this custom-built profile, the data quality rules to cleanse my data. So that's what we are doing, and the good thing is all these things, we are not moving the data in and out of Hadoop, because once the data is on Hadoop, what we are doing is we have a way of we have our power. With the power of our engine, we can actually abstract the execution environment from our customer. So that means if today, if in this conference everybody is talking about Spark, maybe tomorrow there will be Flink or something else, what we are saying to our customer is, once you use Informatica Big Data Edition, you don't have to worry about these technology changes. With this single change, right, what I've done here is I've just changed my execution environment to Hive. What we are doing is we are converting this entire mapping into MapReduce. And we recently announced in this conference the support of TES, so we can also support TES as well as we support MapReduce, and we have plans to support Spark and other technologies as well. But as a user or as a developer, you don't have to learn these technologies. So what we are doing here is by single click here, we are converting this entire mapping into MapReduce, and which is running natively into Hadoop. So you don't have to learn these technologies. So you have, once you know how to code in Informatica, you can actually pretty much take the advantage of big data processing. So that's what I'm doing in this job here, where I'm cleansing my data using the pre-built rules from data quality. And once I have all this, the next thing I want to show you is the HIPAA files. So those of you who haven't seen HIPAA files, it looks like this. So this is a HIPAA file where it gives you some important information about where is your clinic information, what disease this patient has been diagnosed, how much days he has spent in this hospital. So what we want to do is we want to take this HIPAA file and extract the meaningful data out of it. So that's what we do in Big Data Edition, where we not only give you a way to do ETL and data quality, we can also take any unstructured data, we can parse semi-structured and unstructured data, and we can get meaningful information out of it. So that's what we are doing in this job here, where I'm taking a HIPAA file, extracting the meaningful information, joining it with the clean data to come up with some recommendation. So that's what I want to show. With the interest of time, I just want to show you that with this one, once you use our Big Data Edition, you can now use Tableau or any other BI tool to do reporting, where you can find out which clinic is doing, like in this particular case, we found out that this particular clinic is taking the longest time to cure cholera. So like that, Sarah can make a decision on which provider is doing good over a period of time. And the last thing I want to show you is our way of doing metadata management. So this is of all the things which we have done, like moving data onto Hadoop, doing the data intelligence, and then parsing and moving the data out. All those things you can see from our metadata manager, where we can show you the end-to-end lineage of everything which is happening, not only on Hadoop, but also on the data preparation and also on the data extraction side. So with the interest of time, I'm going to conclude my demo here and going to open it up for any questions. Any questions?
Can you process data not in a linear fashion, but maybe if one step of cleanup takes longer than others, do that while you're doing other cleanup, maybe in unrelated fields?
Yeah. So the question is, can we take a data flow, and can we make it in a different way, where one flow is not related to the other flow? So what we do, as I said, is when we take entire mapping or entire workflow which you create in Informatica, we convert that into MapReduce. So, and then the MapReduce is the series of jobs which are coming up in parallel. So if there are jobs which can execute in parallel, yes, we can do that. So it's as similar as writing a MapReduce code. Yeah. So the question is, as a performance side, as a developer, what are the best practices? So I think the best practices is whatever Hadoop best practices is, right? So like for yeah. Yeah. Right. So I think what we are trying to do is we are trying to abstract our developers with Hadoop, all these way of all these technology changes. So what we are doing is we have our own optimizer which decide what is best for a job, like number of mappers and reducer. And if you are a power user and you know, I really want to use like 10 reducer or 10 mapper like for your hand coding, we do have ways where you can use our advanced properties and you can pass on all these parameters. So we have ways for advanced users, but if you are not an advanced user, if you are just beginning, if you are an Informatica developer who know how to code in Informatica, you can still use Informatica to do that, and our optimizer will take care of it. Any other questions? Yeah. How many, so the question is how many, so data quality transformations, how many of them are custom and how many of them are reusable? So out of the box, we actually give, I think we are the only tool which gives you more than 20 to 25 transformations just on data quality. So if you are familiar with Informatica data quality products, and we are the leaders in Gartner quadrants on data quality. So all those transformations which you are seeing, so just to give you a view, right? So all these, in the backside, all these palettes here, all these are the transformation which you will get out of the box, which will work on Hadoop. Will be like 25 to 30 transformation which will run. But if you find something which is very rare, that if it is not available, we have ways by which you can plug in your code as well in this tool. Sorry? Yes, so we can automatically detect and we can create some transformations. So like for example, as an analyst, if I know that these are the things which I want to use to prepare my data, I always know that I need to filter this column, I need to take these things out, we will automatically do it for you. But if you're an IT developer, you know that after they say, I want to aggregate, I want to cleanse my data, just like what I'm showing here, you can also custom build your transformation. So we have an analyst tool by which we can prep your mapping logic. And once you do that, if you want to add more transformations, you can do that using our Informatica developer tool. There was a hand over here. Yeah.
Are you able to leverage partitioning at the session level when it gets to do?
Right. So for partitioning, so we do have, so since what we do is we convert entire thing into MapReduce, and the MapReduce itself has a way of partitioning the data. So we pretty much use that framework. We also support like Hive partitioning and any other partitioning functionality which Hadoop provides. So yes, we have different way of partitioning our data. Yep. Yeah. Absolutely. I mean, most of our customers are doing that, where they have certain things which use a Power Center, and then they have certain things where they are using this tool. So we have a way of using command line by which you can automate all those things, and you can call this scripts from our command line transformations from Power Center. So Power Center provides a command line, and from a command line, we have an APIs to call all these things which you are developing in this tool over here. So yeah, that's possible. Any other questions? Yes. Yes, so we do have a way of even moving data into real time onto Hadoop. We have a product called BetaStream, which actually helps to move data into real time onto Hadoop. So similar to like what you see in Kafka and Flume, similar to that we have a BetaStream which can move data into real time. No, we use the same open source technology. So the whole idea is that we want to embrace open source wherever it is good, and we want to add a value top off on it, right? So what we are saying here is, we're not saying that Scoop is bad or there is any other open source technology which is bad. But what we are trying to do is, if you use Scoop, you are actually losing the metadata information. How will you see the lineage of the things which are, how you are moving your data, how you are happening it. So we are adding a value top on top of it. So we use MapReduce or any other languages, just like you write Hive scripts and Pig script. What we are doing is we are giving you an abstraction and giving you a future proof that tomorrow, if the technology changes, for us it is very easy to add these technologies. So you, as a user, you don't have to worry about it. Any other last question? We have only a few seconds. Yeah. Yes, so since, as you have seen, we have like very rich transformation suite where we have so many things which Hadoop itself cannot do. For example, Hive, there is no way of doing data quality. There is no equivalent of Hive in doing data quality transformation. So what we do is we install a small libraries, which is like 500 megabyte, just the libraries on all the nodes of Hadoop. And we work with Ambari and we work with Cloudera Manager for that. And these are not the active running processes, these are just the files. And the reason we have these files is because whenever we see a transformation which is not natively supported by Hadoop or Hive, for example, we will use the Hive UDF layer to call to our library. So that as a user, you will get the entire functionality of Informatica, even though Hive doesn't support it. Yes. Yes, so everything, whatever we do is we are running on top of Yarn. We are a good citizen in Yarn framework. So we are not trying to install our software on top of Hadoop and trying to compete with Hadoop resources. We have everything totally integrated with Yarn. Yes. So with that, thank you all. Thank you all for joining the session.